Hello, my name is Omar and today I will show you how to make a frequency distribution and histogram using LibreOffice Calc. What is a frequency distribution? The organization of a set of data in a table showing the distribution of the data into classes or groups together with the number of observations in each class or group is called a frequency distribution. This is an example of frequency distribution table. It consists of 8 classes: class limits, class boundaries, class title, and frequencies. This is a histogram based on the data available in the previous slide. On x-axis we have class boundaries and on y-axis we have frequencies. So how to make a frequency distribution? A frequency distribution and histogram can be made by following these steps. First, calculate the number of classes. The number of classes are usually denoted by letter K. Then calculate the class interval. Class interval is usually denoted by H. Apply frequency formula in LibreOffice Calc sheet and make a frequency distribution table. After making the frequency distribution table, create a bar chart based on the frequency distribution and set the properties of the bar chart to convert it into a histogram. There are two methods to calculate the number of classes. Method 1, k is equal to 1 plus 3.3 multiplied by log n. And method 2, k is equal to square root of n, where k in the above formula is the number of classes and n is the total number of samples in our observations. Let's see some example. Calculate the number of classes and class interval. First, we see the example of calculation of number of classes by method 1. If we have total number of observation 100, then k is equal to 7.6. The number of classes are always a whole number. The result obtained from the method 1 formula is containing a fractional portion. So we rounded it up to the next whole number, which is 8. So therefore the number of classes by method 1 when the number of observations are 100 is 8. According to method 2, k is equal to square root of n. We have total 100 number of observations, so we will take the square root of 100. Therefore k, the number of classes by method 2 is 10. Next, we will calculate the class intervals. Class interval is equal to range divided by number of classes, and range is the difference of maximum value and the minimum value in our data set. The data set I have used for my demonstration has a range of 3.3, and the number of classes obtained by method 1 is 8. Therefore, I have put these numbers to the formula and get the result of 0.4125. My dataset, which I have used for the demonstration, contains observations which have a significance level after decimal is 1. So I have rounded the class interval to 1 decimal place. Therefore, the number of class interval is 0.5. Next, I will show you how to apply these methods on LibreOffice Calc sheet. Different days, we have total 100 observations, and the level of significance of observation is up to 1 decimal place. First, I define a range of my data so that it will be helpful later in calculations. There are total 100 observations. Now I will add a new sheet, renaming it to stats. This sheet will hold the statistics of my dataset, and I will create a frequency distribution table in this sheet. So to calculate the statistics of my dataset, go to the data menu, select statistics, select the descriptive statistics, define range, the input range has been defined. Now I will define the result range. I need result on the second sheet named stats at the first cell. My data is in column, so the data is grouped by column. Group by column is selected. If your data is in rows, then you will select the rows. So press OK. These are the statistics about the dataset I am using. For my calculation, I will be required the range, so I am highlighting it. Let's increase the view. I will be required range, minimum and maximum values, and total number of observations. The formula for calculation of classes which I am using is from the method 1 I have presented in my presentation. So the number of formula is 1 plus 3.3 multiplied by log n. So 1 plus 3.3 multiplied by log n. N is the number of samples in my data set, which is 100. So we get the result of 7.6, which is not a whole number. It contains fractions. To convert it to the whole number, we will round it up to the next integer, which is 8. So k, the number of classes, is 8. Next, we will the class interval will be calculated. The formula for class interval is range divided by number of classes. So the range from the statistics is 3.3 divided by number of classes 8. The result is 0.4125. My data set consists of observations up to 1 decimal place, so I am rounded it up to the next up to the 1 decimal place. So h, the class interval, is equal to 0.5. Now I will define the format of my frequency distribution table. First serial number, then class interval, low and high value, class boundary, class title, and frequency. Let's apply some formatting for better visibility. We have calculated total 8 number of classes. So I have defined 8 serial numbers for my classes. Now we have to define the lower class limit of the first class. It is always less than the minimum value in the data set. So the minimum value in our data set is 12.4. So we will require to define a value less than 12.4. So I am selecting 12.0. So 12 is the lower class limit of the first class. The class interval calculated is 0.5, but we will not use the 0.5 for the first for the class interval in the first class, but we will use a value less than the calculated class interval. So I am defining a class interval of, I'm using a value of 0.4 which is less than 0.5 and add it to the lower limit of the interval. So lower limit is 12 in this class and I am adding 0.4. Next I will use the calculated class interval which is 0.5 and add it to the lower class limit of the previous class. 12 plus 0.5 which is the calculated class interval. The reason of using a value less than the class interval in the high column is because if I do not use a value less than the class interval in the high column, the two cells, the two classes will overlap. Now we have two different, there we have a gap between the two classes 12.4 and 12.5.1. there is a different gap of 0.1, so no values are overlapping each other. Otherwise, if I use a value of same class interval, suppose 0.5, then it will be difficult, then the data will be overlapped. It will be duplicate in both classes because both have the same values in their classes. Both classes are containing 12.5. The previous class is containing that 12.5 in the upper limit and the next class is holding that 12.5 in the lower limit. So it will be confusing and result in error in our calculation. So therefore we will use a value less than 0.5 which is the class interval in the high limit column of the class interval. See, now the two columns have distinct values. Two classes have distinct values. They are not overlapping each other. So for the high value for the second class, I will simply copy the value of the previous class. It is containing a formula, Control V, and the upper limit or high value for the class interval for the second class is defined. Now I will copy the record of the second class and paste it to the remaining classes. The level of significance for each class is up to 1 decimal place. So I am defining a formatting so that it can show up to 1 decimal place. Let's adjust column width of each column. Next we have to define the class boundary. A class boundary For defining the class boundary, we will subtract a value less than the class interval into the lower boundary of each class and add the same value in the upper boundary. This way we will mitigate the effect of subtraction of the value from the lower class. So the class interval is 0.5. To define an appropriate class value, I will add into or subtract a value less than class interval, which is 0.5, and we have to make the data up to 2 decimal places. So I will minus 0.05. Similarly, I will add the similar value 0.05 in the upper class interval, and then copy to the next rows. So these are the class boundaries, and class boundaries are used in our histogram. Next, we have to define class title by concatenating the lower class boundary and upper class boundary. Copy them to the next rows. So these are our class title. Let's see whether any value is missing from the classes. The class title of the lower value of the first class is 11.95, and the minimum value we have calculated for our data set is 12.4. So 12.4 is included in my class title, first class title, and the maximum value is 15.7, and the last class of this table consists of the upper value of 15.95. So 15.7 is included in the last class. So now we will apply the formula of frequency available in the LibreOffice Calc. It has 2 parameters. The first parameter is the data, and the second parameter is classes. I will use the already defined data range for my data set, DS mileage. Now for the classes, we will select the range of the upper class boundary and then close the bracket. Please remember, do not press enter. To complete this formula, we have to press the Control and Shift keys and hold them, and after pressing and holding the both keys, we will press a third key the enter key, and the frequencies will be calculated. As you can see, the total number of frequency is 100. Now apply some formatting so that it can be better visible. So this is our frequency distribution table. Now we will make a histogram based on this frequency distribution table. To make a frequency histogram, we will add a new sheet. Rename it to histogram. Now from the toolbar, press the insert chart button. From here, go to the step 3, data series, and press add. We have to define the range for y values. The y values hold the frequencies we have calculated in the frequency distribution table. So to define the range for y values, we will go to the stats sheet and select the frequencies column. These values are selected, and for categories we will use the class title column in the stats sheet. Press next. Disable the display legend. Type the chart title. On x-axis we have classes which contains kilometers, and for y-axis we have selected the range of frequencies, so we'll define it. Press finish button. This is a bar chart. To convert into histogram, we will select any bar in our dataset and press the format selection. In these settings, set the spacing to 0. Set the transparency to 50 and set the border to continuous line and make a thicker line and press OK. So this is a histogram which is converted from a bar chart. It was earlier containing spaces between the bars, which has been eliminated by setting the properties. Now adjust the font size so that it can be better looking. We can also define the values for each bar by going to Insert and clicking on the data labels. Show values as number. Now the frequency of each class is available on each bar. As you can see, we have available all the values available in this histogram. So users, this is the procedure how to make a histogram using a frequency distribution table in LibreOffice Calc sheet. I hope this will help you in making the frequency distribution and histogram. Please like the video. Thanks for watching.